Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. So today we will discuss in this session that motion under gravity. So learning outcomes. At the end of this session, the students will be able to analyze free fall and vertical motion under the gravity. So first of all, we will see the equation of motion in a straight line, so that we can connect these equations to the vertical motion under gravity. So equation of the motion when a body is moving in a straight line. Let us say a body is there, here it is kept on this surface. Now let us say u is the initial velocity and it moves like this from one point to other point. Let us say it covers a distance s. The final time taken for this is t and the final velocity is v of the body. Okay, and let us say a be the acceleration of the body. Then we know the formula for acceleration. Acceleration is equal to change in velocity upon time. So change in velocity means what? Acceleration is equal to final velocity minus initial velocity. Final velocity is v, initial velocity is u. So it is v minus u upon t. So if you rearrange the equation, you will get at is equal to v minus u. Then here if you reshuffle, you send this v to this side, you will get this final equation, v is equal to u plus at. This is our first equation for the motion in straight line. Again, if you reshuffle this formula from this step, what we will get? Time t is equal to v minus u divided by, send this a to this side, divided by a. So okay, so now distance covered. How do we calculate normally the distance covered? It is average velocity into time. So average velocity into time means distance covered is s is equal to u plus v by 2. It is the average velocity, initial plus final, multiplied by time t. So here in this equation, if we put v is equal to u plus at, from equation 1 we can see that v is equal to u plus at. So instead of this v, if you put u plus at in this equation, what you will get? S is equal to, here u plus u 2u plus at divided by 2 into t, or we can take this 2 outside and it will be t by 2. So here after simplifying we can write S is equal to 2u plus at into t by 2. So if you simplify this, what you will get? S is equal to ut plus half at square. So if by this t by 2, if you multiply 2u and if you multiply at, then you will get this thing. So this is your equation for the displacement. Again, we know that S is equal to average velocity into time. So here u plus v by 2 and t is equal to, from equation 2, t is equal to what? V minus u upon a, that we have seen. So if you replace this t by this v minus u upon a, then further if you calculate, then it will be S is equal to v plus u into v minus u upon 2a. So a plus b, a minus b. That formula we can apply over here and it will be a square minus b square. So it will be, if we transfer this 2a to this side, it will be 2as is equal to v square minus u square. So if you reshuffle the formula, you will get v square is equal to u square plus 2as. So these are the equations of the motion when body is moving in a straight line. V is equal to u plus at, this is our first equation. S is equal to ut plus half at square, this is the second equation, and v square is equal to u square plus 2as, this is your third equation. Now we will see the motion under gravity, how this equation changes. So now see linear motion. In this column I will write the equation of linear motion, and here motion under gravity, it is for downward motion and upward motion. For both we are going to write the equation. So see, this is the first equation when v is equal to u plus at in the linear motion. So here a is replaced by acceleration due to gravity in the motion under gravity. A is replaced by g, and g if the motion is downward. So if the motion is towards acceleration due to gravity, then this g is taken as positive. And if the motion is upward, that is the motion of the object is against the acceleration due to gravity, then this g is taken as negative. So here you can see v is equal to u plus at, here v equal to u plus gt, v equal to u minus gt. Similarly here s is equal to ut plus half at square. So here s is the displacement, horizontal displacement. So in the motion under gravity we measure the height, so vertical displacement will be there. So instead of s we are taking here height, and instead of a, g will be there, acceleration due to gravity. If the motion is downward, g will be plus. If the motion is upward, this g will be minus. Similarly, the third equation, v square is equal to u square plus 2as, it is in the linear motion. So for the motion under gravity, v square is equal to u square plus 2gh. So a is replaced by g and s is replaced by h. Now for the upward motion, this plus sign will be replaced by minus sign. Okay, that is plus g is replaced by minus g. Now we will solve problems based on this. So here we can see a sphere is thrown vertically upwards from the top of building 25 meter above the ground. So the sphere is thrown from the top of building which is 25 meter above the ground. So height of building is 25 meter with an initial velocity of 18 meter per second. Determine in what time it will reach the maximum height. So we need to calculate the time at which that sphere reached to the maximum height. How high it will rise above the building. So height also we need to calculate, time we need to calculate, height also we need to calculate. Then calculate the velocity with which it will strike the ground. Okay. So before striking the ground, what will be the velocity of this sphere, that we need to calculate. Next is the total time for which it is in the motion. So total time for which it is in the motion, that also we need to calculate. So this is now the building and this is the sphere. So here you can see the height of building is 25 meter and the sphere is thrown with the initial velocity of 18 meter per second. This is given in the problem, it is thrown vertically upwards. So let us say initial velocity, I have given here the notation u1. Now once it is thrown with the velocity, it will move up like this. Okay, so it will started moving in the upward direction, and when it reached to the maximum height, okay, its final velocity will become 0. So the initial velocity is 18, then it will start moving in the vertical direction, vertically upwards. When it will reach to its maximum height, at that maximum height its final velocity must be 0, it will become 0. And let us say h1 is the height it covers after thrown, and this duration for this motion is t1 second, let us assume. Now considering the upward motion of the sphere, what we can use the formula, we can use v is equal to u minus gt. So here it is the upward motion, so acceleration due to gravity will be minus. So v is equal to v1 is equal to u1 minus gt. So if we put the values over here, v1 is 0, u1 is 18, g is 9.81, t1 is as it is. So if we solve this, we will get the value of t1. So t1 is 1.83 seconds. So from here to here, whatever the time required t1, it is 1.83 seconds. So once we know the time, we can easily find out the h1 now. So for height h1, we can use this formula. h1 is equal to u1 t1 minus half g t1 square. So that is h is equal to ut minus half gt square. So here h1 is equal to initial velocity is 18, time just we have calculated, it is 1.83. If you put the value of g 9.81, this again 1.83. If we solve this, we will get that h1 is equal to 16.51. Similarly, now after reaching to the maximum height, then its downward motion will stop, and but when its downward motion will start, for just a moment its velocity will become a 0. The final velocity in the first case will become the initial velocity in the second case. So your u2 will be 0 and then it will start moving downward to the ground. Let us say the time taken for this journey is t2. v2 is the final velocity of this sphere before striking the ground. Now consider the downward motion. So again h is equal to ut plus half gt square. Now here we are taking it plus as the motion is downward, so acceleration due to gravity will be plus. So now h2 is the total height. So what will be the total height? The total height will be this much, 25 plus 16.51. 25 meter is already the height of building, and above that it has gone 16.51 meters. So total will be 41.51. So if we put this value of h2 here in this equation, what we will get, this will be the equation we will get. Okay, so from this equation we can calculate the value of t2. T2 is 2.90 seconds. Now velocity before striking the ground, v2 is equal to u2 plus gt2. Then v2 is equal to, if you put the value here, you will get v2 as a 28.44 meter per second. Similarly, total time required, so just add both the times t1 and t2, so we will get the total time 4.73 seconds. A ball is dropped from the top of the tower 30 meter high. At the same time, the second ball is thrown upward from the ground. If the initial velocity of the second ball is 15 meter per second, when and where they do cross each other, and calculate their velocities also when they cross each other. So now these are the two balls. The height of the building is 30 meter. So first ball is dropped, so initial velocity is 0. Second ball is thrown vertically upward, so its velocity is 15. And when they cross each other, suppose they cross each other at this level. So now let us say h is the height covered by the second sphere or second ball. So 30 minus h will be the height covered by the first ball. The time required for both the balls or the sphere will be same. Now if we consider the motion of the second ball, so we can use the formula h is equal to ut minus half gt square. So from here, if we put the values, we will get the one equation in terms of t. So that equation is h is equal to 15t minus 4.9 t square. This is our equation number 1. Similarly, if we consider the motion of first ball, again we can use the formula h is equal to ut plus half gt square. So here h is nothing but the distance covered by the first ball, which will be 30 minus h. Initial velocity is 0 as it was dropped, and if we put all the values, we will get this equation. This is our equation number 2. 30 minus h is equal to 4.9 t square. If we solve equation 1 and 2, we will get t is equal to 2 seconds and h is equal to 10.4 seconds. Sorry, 10.4 meter height. So velocity of the first ball, again v is equal to u plus gt, because first ball was moving downward. So now v is equal to u plus gt. If you put the value, u is 0, 9.81 into 2, time is 2 seconds, so it will be 19.62. For the velocity of the second ball, v is equal to again u minus gt, because second ball is thrown vertically upward, so g will be minus. And now v2 is equal to, if you put the value, it is 4.62 meter per second minus 4.62. Okay, so here we get the answer, and these are the references, some of the references which I have referred. Thank you.